we're still working on getting every class at the same spot, doing the same things, having the same homework. So things are not my best teaching. I'm not gonna lie. I'm not super fluid with where I'm going. Everybody, it's a little chaotic. So we will work through that as best we can. And yes, I'm still pretty sure the test is going to be Thursday. Still kind of leaning to Friday though. So I will let you know, pretend right now that it's on Thursday, and tomorrow be happy if I move it to Friday. How about that?
Like this Thursday?
Yeah, like in a couple
Can we play
days.
a game?
Yeah, well, that's why I'm thinking of moving it to Friday, is so that we can have a time for a little bit more fun review, but we are also super far behind, so
So last
I don't know what to do.
time
It's definitely not getting pushed to Monday.
Not
I
gonna look.
missed it.
Half the people won't even.
You
know
did
about
miss it. All right, but anyway, so nope. So we're gonna start by going over the homework. Okay, guys, stay with me. We're gonna start by going over the homework, which was on page 34. And this was just asking, name the parent rock of the following metamorphic rocks. So quick review, where do we find the parent rock?
Comments.
In the comment section. So you go to your metamorphic rock. So if it's looking for, so this case, they gave you the metamorphic rock and you need to find the parent. So you go slate, you go over to the comments, low grade metamorphism of shale. What'd you find for phyllite? Mica crystals. Yep. However you want to say it, I don't care. Schist.
Feldspar.
Clay or feldspar is listed there. Gneiss was not listed, so I'm sorry, I shouldn't have given you that one. It's not, so if you look at gneiss, it doesn't say, it just says it's a high grade metamorphism, mineral type segregated into bands. So they would not ask you the parent of gneiss ever. Quartzite was in there though. Sandstone. Marble has two potential.
Limestone or dolomite.
That dolomite,
It's Dolostone.
dolostone.
Oh, my bad, I wrote that.
So we use.
Now, metaconglomerate technically isn't on there.
I put pebbles.
You could have. But guys, let's look at the word metaconglomerate.
Oh, we could have put co-op.
So it's metamorphism of conglomerate. That's where that name comes from.
That was real creative.
I know they got really fancy. I will say the Regents won't make you put those two connections together, so that they won't ask you about that one either. Name the minerals that may be found in phyllite. How do we figure out the minerals in phyllite?
You look to the left and you're gonna see all the minerals in the composition.
The composition. So how it works is if that bar lines up with the box for that rock, then it could be in there.
Everyone except for the bottom.
So phyllite has all of these guys. It does not have the pyroxene. So it's got mica, quartz. I'll write them out. Mica, quartz, feldspar, amphibole, and garnet. What mineral may or may not appear in a sample of schist? So there's schist. Which one may or may not? The pyroxene. And you can tell because for some of the box for schist, the pyroxene goes up that high. For some of it, it's blank. So that's the one that might be, but might not be. I spelled that wrong, didn't I? I forgot a whole syllable, I think, didn't I? All right. And name the rock that is produced when various rocks are changed by nearby magma and lava. Guys, we love the comment sections. Scan the comment section. Various rocks changed by heat from nearby magma/lava. That's Hornsfeld. Name the metamorphic rock that is, which one is foliated, fine grain, low grade metamorphism of shale? That's slate. I told you could skip this one. I think what I did is I think I got distracted and stopped typing. I think there was supposed to be like more to this sentence. How about then C, foliated high,
G nice.
okay?
Nice.
The high grade metamorphism contains pyroxene and coarse. That one is going to be nice.
I think we should pronounce it G nice.
No, it's too nice to be pronounced G nice.
G nice.
No, that's not nice enough.
You get the joke?
Get it?
Yeah.
Don't take me for granted anymore.
Oh my goodness.
Bruh.
No.
Cause then you might think I was a piece of schist.
No. No. Quartzite.
Earth science rocks.
Right.
Alrighty.
Oh, come on,
Wow,
Sarah.
that was
Don't be
rude.
jelly. You could be as cool as me. All right, we're on to D.
Quartzite.
Okay, quartzite.
And metaconglomerate.
Easy, don't.
Wow. Should somebody else answer?
No.
No. Metaconglomerate.
Dwayne got this on the
Marble's next.
9 slap.
Then slot.
Metaconglomerate is like the longest word ever. What is F?
Marble.
Marble.
And slate. Slot.
Slut.
Slate. How about H?
Feel like.
Highlight.
Mm,
Did
not
you
shit.
say schist? Not schist. I will admit that schist and phyllite are pretty darn close. They're basically they have the same grain size. They have basically the same minerals. The only thing different is when you go through the reading. Phyllite does tell you it's shiny from microscopic mica crystals. And that's what we were looking, right? Wasn't it? Oh, no, this one says
Never can
G
contain.
nice.
never contains
The bar never
pyroxene.
goes up to shut.
Right,
Or-
so phyllate's bar never, oh my gosh, Zach's got
Alright.
me confused. The pyroxene box never makes it to phyllite. Has banding.
G nice. Hornfels.
Contact due to extreme from lava. Yeah, that's Hornsfeld.
Quartzite. And then Shiesty.
Wow. Quartzite and then some schist.
Shiesty.
Did anybody need me to explain or have these two guys explain any of
We
these
can
two?
explain it, guys.
How about it? Does anybody want me to explain one that you got wrong? Did you not get any wrong?
No, Sarah did.
Oh, that's
You
right.
heard Sarah.
Anybody else? How'd you do? No one's willing to admit because we've got Mr. and Mr. Obnoxious in the front here.
You see, we could be in the Mr. and Mr. Obnoxious in the back.
I'm aiming for that, yeah. Goals. Were you good? You got it.
That cat can have a seat back and use it.
All right. What though? So I think that means you're done,
We're done for the day.
except no. We're done with the packet though. I'm curious, and this is just because I wasn't here. What does the bottom of your page 25 look like? It is empty like mine?
25?
Yeah,
25 has some lines on there.
yeah,
but it's empty.
okay. That's kind of what I thought. That was lost in me being absent. So this is sedimentary rocks.
We already did this like 3.
Yeah, you did do sedimentary rocks like forever ago. You know the basics. How do sedimentary rocks get grouped?
Get good.
So wait, you got a test coming up. What do you think this is called that I'm doing right now?
Reveal.
Reviewing. I'm reviewing and then throwing in a few things we must have forgot. So sedimentary rocks, how do they get grouped? If I had 10 sedimentary rocks in front of you, what would be the first
Hang on.
thing you would do
Texture.
to separate them? And I love what Carter just did. He doesn't know off the top of his head, so he grabbed his reference table. Carter, don't speak now. Okay? No one else say anything out loud. All of you open to your sedimentary rock chart.
Don't say anything, Dwayne.
No, I really like your enthusiasm and what you were doing. I just want to give everybody a chance to do the same thing you did. So my question now that you have the sedimentary rock chart in front of you is, you have 10 sedimentary rocks in front of you. What groups do we make? Wait. I want to see you guys point to the groups we're gonna put them in. So that. All right. So the first group, Carter, how do you want to separate them?
Clastic, crystalline,
Bioplastics, the last one.
well, you could do like crystalline and.
Yes, so the three major groups that you're gonna put the rocks in are clastic, crystalline, and bioplastic. Quick review, what does the basics of the word plastic mean?
Fragmental.
Okay, which means it's made out of fragments of rocks. What's crystalline mean?
It's crystal.
Made of crystals. And what's bioplastic?
Living things.
Broken pieces of living things. Okay, you guys got the basics of this, and going through the sedimentary rock labs, you guys were doing pretty good with that. So I'm pretty confident you're good-ish at least with sedimentary rock. Like I said, we did forget the bottom half here. It's just a few words, like barely anything that we have to get. These are just kind of some facts. These are not, nothing, just
I'm
facts.
doing the bottom.
Yeah. This is nothing that's really in your reference table. So this is kind of the have to know off the top of your head stuff. So it says formed in. Sedimentary rocks are formed in horizontal layers. I don't want you to get this confused with the rocks have layers, because what rocks have layers? Metamorphic rocks have layers. That's not what I'm talking about. I'm not talking about the individual rock having layers. I'm talking about when you are out there in Minecraft, digging around, you will find Minecraft. Minecraft is real, dude.
Yeah, dude.
Don't question it.
Dude, Minecraft is fun.
When you dig around in Minecraft, if you dig around in a whole area, you will find a
Diamond.
layer of the different rocks. So sedimentary rocks form in layers over large regions. They do form at or near the Earth's surface. So on the Earth's surface. Why do you think sedimentary rocks made out of sediments, rocks made out of broken shell fragments, or rocks formed when oceans evaporate? Why do you think they're found on the Earth's surface and not buried deep
Because
down
they're
below?
sedimentary rocks.
Well, yeah, but why? Yeah, you're right.
Why?
But why? Huh?
1 second. They're volcanic.
They're not volcanic, what?
Oh, yeah.
They do have to get cemented and compacted, but why is that happening on the surface? Let's go back. What are sedimentary rocks made out of?
Composure.
Sediment.
That are compacted.
Okay, yeah, sediment is good. Where does sediment come from? They could be igneous rocks, but what happens to those igneous rocks? They weather and erode. We have to weather and erode a rock to make sediments before it can get deposited, compacted, cemented together. Where do you think I'm going with this? If they have to be weathered and eroded, where does that happen? On the Earth's surface, you need running water, you need wind, you need waves, you need glaciers to break and move the rock pieces before they can get cemented together. So why do they form on the Earth's surface? Because that's where that's where weathering and erosion happens. So which rocks do you think fossils are found almost exclusively in? Next question. Fossils are almost exclusively found in sedimentary rocks.
I think when we went over those questions a while ago, folks, we kind of talked about like burying the fossils in mud, what happens to those fossils in igneous metamorphic rock. So we try to think back to last week.
So why do you think they're only found in sedimentary? Going off the hints there that Mr. D reminded you from last week.
Because they're like inside the earth,
Okay, so what's a fossil made out of?
bones,
Bones. So something that was alive, right? Where do things live?
on the earth.
On the Earth's surface. Okay, so that's one thing. So what's one reason you think fossils are only found in sedimentary rock?
Cause they need weathering and weather,
What's on the Earth's surface?
the fossils.
The sedimentary rocks are on the surface. So that's one. So one reason is because sedimentary rocks are on Earth's surface. Now here's another reason. You're a dinosaur marching around.
No, I'm not.
Okay, you're marching around and you're about to become a fossil. So you pass away.
Aw.
Okay, you passed away and you're about to become a fossil and you hop in some lava and say, this is a great idea. What's going to happen to the dinosaur and its bones if it hops in hot molten lava? It's gonna completely melt. Will there be any evidence that that dinosaur was once marching around? Nope. So then that marching around dinosaur is like, I'm gonna become a fossil. I should check out this metamorphic rock. What happens during the formation of a metamorphic rock? Intense heat and pressure. How's that dinosaur gonna hold up with intense heat and pressure?
It's gonna melt.
It's gonna get totally not gonna melt, remember, because metamorphic rocks
It's gonna
don't
melt
do that.
until they're
Like
gone.
But it's gonna get too gooey. The bones might melt, you're right, because they're not rocks, they might melt. Good point. It's gonna get destroyed though. There's gonna be you're not gonna be able to put together that fossil. So now we've got a dinosaur hopping around. And it's like, I'm gonna check out this sedimentary rock. So it lays down. What happens around it to make a sedimentary rock? What happens with the sediment? They get deposited on top of it. They get a little buried, a little compacted. How's that dinosaur doing around all these buried, compacted sediment? Just hanging out like somebody all nice and cozy in a bed, right? Got nice layers of sediments on top of it, but it's not gonna get destroyed. So sedimentary rocks are the only ones that won't destroy a fossil. So I want to add that. So number 2, because the formation of other rock types would destroy them. For example, we already did this, igneous rocks, fossil would melt. Metamorphic rock, fossil would be destroyed. And the last bullet to finish chapter 3's learning. No. The last thing you need to understand, it says fossils provide, and the sentence will be evidence of past environment. What the heck does that mean? Fossils provide the evidence of past environment. How about if you found a fish fossil? What does that mean? Used to be the environment of that area? Water. What if you found a scorpion fossil? Where do scorpions live? In the desert. What if you found a tree and an eagle and a squirrel fossil? Used to be a forest. Okay, what if you found tropical ferns and palm tree fossils? What'd you say? Yeah, like a beach area or a tropical rainforest type situation. You got it. So what I'm saying is the fossils that you find give you an idea of what the area used to be like, whether it was a desert or a beach or a tropical rainforest or an ocean. Okay, so we still have some major reviewing to do. But we have learned everything.
We have all of them.
So you have homework. It's something some of my other classes have already completed. We're gonna do some reviewing.
By ourselves.
On the bottom of 37, see where it says mineral and rock unit review?
Yes.
There's 5 questions there. And it goes up to question 38, or it goes up to question 35 on page 38. Yes, 35 questions for homework is more than I always give,
35.
but
we
you
have-
have 15 minutes right now,
Actually,
actually 16. So your homework / work you're doing right now is page 37 and 38, but not the top part. We're gonna do that tomorrow in class. We're reviewing we're doing the mineral and rock review. So this is homework. Where will you get most of these answers from? Reference table, what pages?
16.
So the ESRT, page 16, that's the minerals. 6 is the igneous. And 7 is metamorphic and sedimentary. You might also want to use the rock cycle chart if you need that too. So you're using your reference table, page 6, 7, and 16 to do these 35 questions.
Please.
Sure.
So then you go.
No, when we work with a partner.
I'm saying you put this reference there, at mine at 16.
Oh, okay. So again, when we work with somebody, make sure you're both looking up the answers, not just half and half.